Hello guys, ഞാൻ Alex Sebastian. ഞാൻ ഇന്ന് സെമിനാർ എടുക്കാൻ പോകുന്ന ടോപ്പിക്കാണ് path matrix. What will be covered in this seminar? ഈ സെമിനാറിൽ ഞാൻ എടുക്കാൻ പോകുന്നത് what a path matrix is, how to find a path matrix with an example. What is a path matrix? A path matrix P of ij is a simple digraph that are in the form of Boolean displays. That means ബൂലിയൻ ഔട്ട്പുട്ടിലായിരിക്കും മാട്രിക്സ് തന്നേക്കുന്നത്. എക്സാമ്പിൾ 1 for true and 0 for false. It is also called reachability matrix because it determines reachability from one node to another. Basically, path matrix shows the path, shows the path between two different nodes. It can be two at most, like n number of nodes. How to represent a path matrix? A path matrix P is equal to P of ij. This is marked as 1 when there is a path between V from node V of I to V of j. Otherwise, it is marked as 0. To explain how to find a path matrix, we need the following. As we have studied in the previous seminars, everyone knows what an adjacency matrix is. So, A is equal to adjacency matrix and P of ij is the digraph. Then, if and only if there is a non-zero element in ij entry of the matrix Bn, Bn is represented as a square plus a cube plus a raised to 4 plus a raised to 5 and adds on till a raised to n. Over here, A is the adjacency matrix. And to understand this, to solve this problem, we'll take a example diagram. So over here we have an example diagram with 6 edges. That is A, B, C, D, E, and F. So we'll be considering the path between V1 and V2. So how can we connect V1 and V2? So over here we get 3 paths. One is D, then the other is EC, and the other one is E, F, B, and C. So we can see here that from V2 to V1 we get the first path, that is D. It is a direct path because it just leads from V1 to V2 to V1. The other one we go down to E, then we take the diagonal C to V1. The other one, we take the same path as E, but we go under. From we go to F, then to B, then we take the diagonal to V1. So these are the 3 paths that we have between V2 and V1. So therefore, there'll be 3 rows in our path matrix and 6 columns. The 3 rows are the 3 paths, and the columns are the number of edges. So we get a 3 into 6 matrix. So over here we have plotted the matrix, and to understand this we are going to take it as the first row is of the first path, the second row is of the second path, and the third row is of the third path. And we give the path as like 1 or 0 if there is a connection. So in the first row we are taking the first path, which is only D. So every other element A, B, C, E, and F will be 0 except D, because only there is one path, that is D. In the second one we have E and C, so we only mark 1 where there is a path, the rest all 0, and that is continued with the third one. Now let's look at some properties of path matrices. So the first property is a column of all zeros corresponds to an edge that does not lie in any path. Okay, this means that let's go back to the example, and over here in the example we can see that there is a column of zeros, okay, which is A. That means that A does not lie in any path. That means we can check the paths, okay. In path 1 it's only D, in path 2 it's EC, in path 3 it's E, F, B, and C. There is no A in any of these paths. So this is what the first property is explaining to us, that if a column of all zeros, that means that edge does not lie in any path. So A is that edge in this property. So let's go to the next one. The next one, a column of all ones corresponds to an edge that is present in every path between x and y. This means that just imagine in column C, if we had all ones, okay? The problem is we don't have an all ones. If C was an all one, it means that including path 1, there'll be C present in all of these. In path 1, there'll be C. In path 2, there'll be C. In path 3 also, there'll be C. That is what the second property is telling us. The third property, there are no rows with all zeros. That means in the example itself, we can see that there are no rows with all zeros. This is because if there is a row with all zeros, it negates the definition of a path matrix. That means it does not have a path. That is not possible. So that is the third property. And the fourth property, the ring sum of any two rows in P of xy corresponds to a circuit or an edge disjoint of circuits. Okay, this means that I hope everyone knows ring sum. So of two rows. Okay, so let's take the two rows. Let's take path 1 and path 2. Okay, D, E and C, there are nothing in common, so we have to take all these three edges. So if we take E, D and C, we get a closed circuit over here. E, C and D, we get a closed triangle over here. We can see on the top part of the example. So that is what the fourth property is trying to tell us. If you want, we can take the second one too, second and third too. E, C, E, F, B and C. E and C are common, so F and B. So we can see that F and B over here at the bottom gives us a closed circuit. So this is what the fourth property is trying to tell us. And this is all we have to talk about path matrix. I hope you understood everything I said. Thank you.